Imagine a universe with no light at all. No sunrise, no stars, no mirrors, no rainbows, no telescopes pointed at distant galaxies. Now imagine a young patent clerk in Switzerland in the year 1905 trying to understand the nature of reality in that universe. What would he have found? What would physics even look like without the one thing that built almost every equation Albert Einstein ever wrote? The answer is far stranger than you would expect, and it starts with a question most people never think to ask. Einstein's entire revolution was built on light, not metaphorically, literally. His most famous breakthroughs, from special relativity to the photoelectric effect, all begin with a beam of light and a simple, almost childish question. What would it look like to ride alongside it? So if you take light out of the picture, you are not just removing a topic of study, you are removing the exact tool that let one man rewrite the rules of time, space, and energy. But here is what is fascinating. Take away visible light, and you do not erase the universe's need for a cosmic speed limit. You just hide the clue that revealed it. In 1865, 4 decades before Einstein, a Scottish physicist named James Clerk Maxwell wrote down a set of equations describing electricity and magnetism. Buried inside those equations was a number, a speed, that matched the speed of light almost exactly. That was the thread Einstein pulled on. Without light, there is no obvious thread, but the underlying physics does not vanish. Electric and magnetic fields still ripple through space. They still travel. And in any universe with fields like that, there has to be some fastest possible signal, some ultimate speed at which cause can produce effect. Light just happened to be the messenger that let humans notice this speed by accident, simply by looking up at the sky. So take the messenger away, and the message still exists. It just gets buried far deeper. But there is another layer to this, because Einstein did not only need light to exist, he needed to be able to measure it, chase it, and compare it to other things moving at different speeds. That is where his most famous thought experiment comes in. At 16 years old, Einstein imagined running alongside a beam of light fast enough to keep pace with it. He asked what he would see. Would the light appear frozen, like a wave stuck in place? Classical physics said yes, but that answer felt wrong to him, almost impossible, because a frozen electromagnetic wave violated everything Maxwell's equations demanded. That contradiction gnawed at him for 10 years. It eventually forced him to conclude something radical. The speed of light is not just fast, it is fixed. The same for every observer, no matter how fast they themselves are moving. Space and time had to bend around that constant, not the other way around. Remove light, and you remove the thought experiment. No beam to chase, no frozen wave to imagine. So where would that leave a mind like Einstein's? Here is the part nobody talks about. Light was never really the point. The constant was the point. Light simply happened to be the fastest, most universal carrier of that constant that nature offered up for free. In a universe without light, other messengers still exist. Gravity, for one, propagates as a wave through space-time itself, and modern physics tells us gravitational waves travel at exactly the same ultimate speed that light does. Radio waves, X-rays, and gamma rays are all light too, just at different wavelengths our eyes cannot see. So removing visible light does not remove the entire electromagnetic spectrum, only the sliver of it humans evolved to detect. But suppose we strip away electromagnetism altogether, for the sake of argument. Even then, gravity remains, and a sufficiently curious mind, in a sufficiently strange universe, could still find that same speed limit hiding inside the mathematics of gravitational attraction, the same way Einstein later did when he built general relativity in 1915, a theory that barely needed a photon at all, only warped space-time and falling apart. So maybe Einstein without light is not a physicist without his tool. Maybe he is a physicist forced to find the same truth through a harder door. But there is a deeper problem, one that goes beyond equations, because a universe with no light is not just a universe missing a phenomenon. It is a universe that could not support anyone capable of asking the question in the first place. Stars form light as a byproduct of fusion, the very process that forges the carbon, oxygen, and iron inside every living cell. Photosynthesis, the mechanism that built almost the entire food chain on Earth, runs on captured sunlight. Human eyes, human brains, and human curiosity all evolved inside a world drenched in electromagnetic radiation, shaped by billions of years of creatures learning to sense it. Strip light away entirely, and you do not get a dark version of our world. You get a world unlikely to grow anything resembling a physicist at all. So the thought experiment quietly turns on itself. The version of Einstein imagining a lightless universe could only exist because light already shaped every atom that made him. Still, physicists love asking impossible questions, because sometimes the impossible question reveals what was hiding in plain sight. And here is where the story takes an unexpected turn. Because when people retell Einstein's chasing the light thought experiment, they often frame it as a young genius simply having a clever daydream, one flash of teenage insight that led straight to relativity. But that reading is not quite what actually happened, and it flattens something far more interesting. Einstein himself, decades later, admitted that the thought experiment alone did not hand him the answer. It took him nearly a decade of frustration, false starts, and failed attempts before the pieces clicked into place in 1905. The daydream was not the discovery. It was the splinter that never let him rest, the itch he could not ignore, even as every other physicist around him treated the speed of light as just another number to plug into an equation, not a fixed pillar holding up the entire structure of the universe. That distinction matters because it reframes the whole question posed at the start. If you remove light from Einstein's universe, you do not just remove an object of study. You remove the 10 years of stubborn irritation that a contradiction demanded to be solved. Genius, in this story, was never about the flash of imagining the beam of light. It was about refusing to let a strange, uncomfortable puzzle go, long after everyone else had shrugged and moved on. So picture that universe again, the one with no starlight, no sunsets, no glinting mirrors. Somewhere in it, perhaps, there is still a fastest possible speed woven into the fabric of space, still a set of equations waiting for someone patient enough to notice the contradiction hiding inside them. Light gave humanity an easy window into that truth. Without it, the truth would not disappear. It would just wait longer, hidden deeper, for someone stubborn enough to go looking anyway. Maybe that is the real lesson buried in the question. The universe was never obligated to make its secrets visible. It simply happened to leave one blazing, unmistakable clue scattered across every night sky, and one curious mind refused to look away from it until it made sense.